Hello, my amazing students. This is Mrs. A, and we're starting 2.2, and this is actually problems 2, 3, and 5 put all together here. And our two functions are f of x and g of x, and we're to find f minus g of -1. Now, when we're given a task like this, and they only want the difference at -1, we really don't have any reason to find the difference at x. So we're just going to take the shortcut on these because we'll be doing the long way later. So remember that f minus g of -1 is the same thing as f at -1 take away g at -1. So we can plug them in individually. So f at -1 means I plug in a -1 here, and I get -1 squared, which is 1. Take away a 3, which is a -2. So this one becomes -2. And then g of -1 is the g function with the -1 plugged in. So that's going to be -2 plus 1, which is a -1, but then it says a minus a -1. So that's going to be a plus 1. So we end up with a -2 plus a 1, which would be a -1 total. So that was the first one, which was number 3 in your book, and the answer was -1. So now we're going to do this one, f divided by g of -1/2. So that's going to be the same thing as f of -1/2 divided by g of -1/2. Okay, so when we plug g of -1/2 in, we end up getting -1 plus 1, which is 0. And we know that anytime we divide by 0, it is undefined. Therefore, this composite quotient function here, the quotient function at -1/2, does not exist. Does not exist. Does not exist because there is a 0 in the denominator when you plug in a -1/2. So then we have f times g of 0. So when we plug f of 0, we're going to get a -3. And g of 0 is going to give us a 1. And -3 times a 1 is a -3. And there you have it. So we'll be back with some more. Okay, so now we're going to look at problem number 17, and we're talking about domain here. We have two functions, and we're going to talk about each function individually and its domain, the sum, the difference, the products of f and f and g, and then some quotients here. Now, the nice thing about these two functions is they're both linear. And since they're linear, their domain, each individually, is all real numbers. Okay, so the domain of f is all real numbers, so we could write that as -infinity to +infinity, because it is linear. The domain of g is also linear. It's a line, so -infinity to +infinity. Okay, the sum of two linear functions is going to be a line again, and the difference of two linear functions is going to be a line. So we can put a little ditto mark for all of those. They're all real numbers. When we come over here and multiply two lines together, we're going to, if we FOILed those together right now, we would get a quadratic equation, an x squared. This one would have a -10x squared as its lead term, and we know that that's a parabola, and parabolas have a domain of all real numbers. So these two product functions have all real numbers as well. So now we're going to get down here to our quotients. When we have a quotient, we have to worry about which one is going to be in the denominator and what would make the denominator go to 0. So we have a g function in the denominator here, and so we have to look up here at the g function and say what would make that function go to 0. So we can set it equal to 0, and then we're going to set that equal to 0, and the number that would make it go to 0 would be a 3/5. So we can't let it equal 3/5. So we're going to have negative infinity to 3/5 union 3/5 to positive infinity. So negative infinity to 3/5 union 3/5 to infinity. Okay, so when we're doing this one, the g over f function, we're looking for what will make the denominator go to 0. So then we're going to set the f function equal to 0. And the answer to that is going to be negative 3/2. Negative 3/2 will make f go to 0. So that's what we have to exclude from this domain. So we will have negative infinity to a negative 3/2 union a negative 3/2 to infinity. I don't have room to put the infinity there, but that's negative infinity to negative 3/2 union 3/2 to positive infinity. Excuse me, negative 3/2 to positive infinity. So we're only taking out the one value that will make the denominator go to 0. So those are your domains. So now we're going to take the same functions here, and we're going to add them, subtract them, multiply them, and divide them. And now, unlike problems 2, 3, and 5, we're going to find the sum of x, which means we actually have to take each function, the f function, which is 2x plus 3, and the g function, which is 3 minus 5x, and we need to add those together. And if I add a 2x with a negative 5x, I end up with a negative 3x, and a 3 plus another 3 is going to be 6. So the sum of the two functions is negative 3x plus 6. So now I'm going to do this one, and we're going to take the difference of the two functions. Especially when you're taking the difference, it's important to use your parentheses because you'll have a minus sign that has to be distributed. So now we'll write the f function, 2x plus 3, and we're going to subtract the g function, 3 minus 5x. Okay, so I'm going to go ahead with my little red marker here, and I'm going to distribute this minus sign. So that's going to become a minus, and that's going to become a plus, and now I can add so that you can see those signs changing there. Okay, so now when I add them, I'm going to have a 2x plus a 5x is a 7x, and a 3 minus a 3 goes to 0, so that answer is just 7x. So now we're going to multiply them together, and we're going to have to FOIL. So we have 2x plus 3, and then times 3 minus 5x. We could turn that one around if we wanted to, but we don't have to. We're still going to get a good answer. So we're going to get 2x times 3 is 6x. And then the outside would be a negative 10x squared. The inside is 9. And the last is negative 15x. So now let's clean it up and put it in the right order. We need negative 10x squared. And then negative 15x plus 6 is going to be a negative 9x. And then plus the 9. And that should be our answer right there. Okay? Okay, so now we have f divided by g, which is going to be 2x plus 3 divided by 3 minus 5x. And that's not going to simplify it all, but we really should make our exclusion. In other words, x does not equal 3/5. Because anytime we have something in the denominator that could go to 0, we should exclude any values that make it go undefined. So this would be the answer. It doesn't simplify, but we need to include the excluded value. That is the end of problem number 17. Okay, so now we're going to do 23, and we're talking again about domains. And we have a square root x minus 3 and a square root x plus 3 that we're going to talk about. And when we're talking about domains, remember the radicand, what is underneath the radical, cannot be less than 0. It could be equal to 0, but not less than 0. So we have to figure out what would make it equal to 0, in this case 3. And so f is going from 3 all the way to infinity with the 3 included. G of x has a little bit broader domain because it can go all the way down to negative 3 before it would start to be in danger of going to 0. So negative 3 to infinity would be the domain for G. So remember what we said when we're talking about domains of the plus and the minus and the times function. We can only define a sum or a difference or a product where both of the original functions exist. So if f exists from 3 to infinity and g exists from negative 3 to infinity, f is our limiting function, isn't it? It has a smaller domain or a more limited domain than the g function does. So everything is going to have to be limited to the domain of the f function because it is more limited than the g, and we can't have a sum where one or the other of the functions ceases to exist. So the sum has a domain that is the same as the f function. The difference has a domain that is the same as the f function, the one with more restrictions. And the product has a domain the same as the f function. This is the f function times itself, so it has the same domain as the f function. Now we move into division. And division's a little different because we have the same stipulation. We can only have a domain that contains, that is as big as the most restrictive domain between the two. So f divided by g cannot exist where one or the other of the functions fails to exist. So again, it's going to have the domain of the most restricted function. And since the g function is on the bottom, the f function domain is still good for f divided by g. But look at g divided by f. Now our most restricted function, the f function, is not going to be able to work completely because now we not only have to have the denominator cannot be 0. So the denominator would go to 0 when x was 3. Therefore, now we have to exclude x is 3. So this domain does not have the 3 included in it. Okay, so that's a little bit about domains. And now we're going to take those same functions and we're going to add them together. So here's our f plus g of x. And we're just going to add the two square roots together. We really can't do anything to simplify that at all. When we take the difference function, we're going to subtract the 2. Nothing we can do to simplify that. When we multiply the 2 together, we can simplify a little bit, because when we multiply a square root times a square root, we can get the product of the two square roots underneath one big square root. So that one we can simplify a little bit. And I didn't put the quotients on here, but we really can't simplify those either. If we're going to do f divided by g of x, it would simply be that right there, with the restriction that x must not be equal, would have to be greater than, since this cannot go negative, it would have to be greater than a negative 3. X is greater than a negative 3 would be our restriction. Okay, so those are, but, okay, x is greater than negative 3 for the denominator, but the numerator was, that's not even going to be in the domain, because the domain is limited by this one, which says that x must be greater than or equal to 3. Therefore, this one is irrelevant. The domain of the whole function is x is greater than or equal to 3, which we talked about on the last one. All right, so now we're looking at 34. One more problem with domains. Domains are very important when we're talking about functions and the arithmetic or algebra of functions, when we're adding, subtracting, multiplying, dividing. In the next section, we're going to do composition of functions. Very important there also. Okay, so here we have an f function and a g function, which are both what we call rational expressions. They are fractions that have variables in them. And so the f function has a domain that is limited because the denominator could go to 0. And the denominator would go to 0 if x is 4. Therefore, our domain is all real numbers except for x is 4. The g function is all real numbers except for x cannot be 1. And the sum can only be defined where both of the other functions are defined. And since this one cannot be a 4 and this one cannot be a 1, both of them are excluded from the sum function, from the difference function, and from the product function, because the product cannot be defined where one of the functions fails to be defined. Now, f is interesting. When we multiply f by itself, then the restrictions on g don't bother it at all, and we just have f cannot be 4, because x cannot be 4, because we're only dealing with that function. But when we go to the f function and the g function, we have to have both restrictions again, because this one, when we divide by g, we can't have that denominator, the whole function cannot go undefined. And so basically we have those restrictions for most of them. So that is the domain chat on those. So now we're going to actually add, subtract, multiply, and divide these functions together. Now, They could have gotten more nitty-gritty in the book on actually combining those into one expression. I was kind of glad they didn't. They left the answer just like that, adding the two functions together, subtracting the two functions. They did not simplify that at all by getting a common denominator, which would have been complicated. They multiplied them together to get the product here. Just multiplied these two functions together as fractions. And when they divided f by g, they did multiply by the reciprocal. Instead of dividing by g, they multiplied by the reciprocal, which would be x minus 1 over 5, and then they combined them. So that was their final answer for the quotient. So we've done enough of those examples, and now we're going to move on to our difference quotient. Okay, we're going to do this problem and maybe one or two more on difference quotients, and then we'll be done with this section. We have our difference quotient formula here, which is f of x plus h minus f of x all over h. Remember, I told you that's going to be a very useful formula when you get into calculus. We got f of x is 6x plus 2. So this is our original function here. So f of x plus h simply means that everywhere we see the x in the original function, we will replace it with x plus h. And then when we simplify, we're going to get 6x plus 6h plus 2. Okay, so now we're going to take our f of x plus h expression here, and we're going to subtract from it our f of x function, and then we're going to divide by h. So we're going to get 6x plus 6h plus 2, and then take away parenthesis 6x plus 2. But if I take my little red marker and distribute that minus sign, I forgot my other parenthesis, didn't I? Distribute that minus sign through, then that's going to be a minus 6 and a minus 2, and now we can add those two together. So we still have not divided by our h yet. So we have a 6x, but now that's a minus 6x that will cancel the 6x. And we have a 2, but now that over there is a minus 2. So what we end up with is a 6h, and that 6h is going to be divided by an h for that part of the formula. And h divided by h is 1, so we're going to end up with a 6. And the answer, the difference quotient, is 6. So that is the first difference quotient problem that we're going to do, which is 51. Right, so here's problem number 59, and I started with my function f of x is x squared plus 1. So then I wrote my f of x plus h, which is going to be x plus h squared plus 1. Then I distributed my x plus h squared, remember, which is first term squared, the product of the two terms xh doubled, and the last term squared, the h squared, and then plus the 1 minus, now I'm continuing with my difference quotient, remember, it is f of x plus h minus f of x, and there's my minus f of x. And then I simplified that by distributing the minus sign through, so I got all of this over the h, which is at the bottom of the formula. Okay, so having gotten that far before I actually turned on the camera here, now we can cancel our x squared and our x squared and our 1 and our negative 1. Okay, so now we've got a 2xh plus an h squared all divided by the h, which is going to wind up being 2x plus h is the difference quotient. That is number 59. Oops, I saw right before I was about to erase it that this was not a minus h, this was a plus h. Sorry about that. I'm kind of looking at it backwards in the screen. So 2x plus h, because I canceled out the h's there. Okay, so here's kind of a long drawn out one. This is number 64. And our original function was 5x squared plus 4x. So now we're going to have to find out what 5x plus h is equal to. So we're going to have a 5, and in place of the x squared, we're going to have x plus h squared plus 4 times x plus h. Well, I squared the x plus h out here and multiplied it by 5, and then I distributed here the 4x plus the 4h, and I finally came up with an expression for just this 4x plus h. That whole long thing there is the expression for 4x plus h. But I'm nowhere near done, because I have to take this expression and I need to subtract the original expression. Then I have to divide by h. So I wrote the whole thing out, and I went ahead and subtracted this function right here at the end. So this is the whole thing, but I haven't done any of the canceling yet. So get a good look at that. That's quite a long little function. But now we're going to simplify a little bit. So I'm going to get my green marker, and we're going to see what will cancel. We have a 5x squared, but on the other side we have a minus 5x squared. Okay, we have a plus 4x here, but we have a minus 4x here. So it turned into 1, 2, 3 terms left, and now I have to divide each one of those terms by the h. So it's not as bad as it had previously looked, because quite a bit of it canceled out. So I'm left with a 10xh, but when I divide by h, I'll get a 10x. I'm left with a 5h squared, but when I divide by h, I'll be left with a 5h. And lastly, I'm left with a 4h, but when I divide by the h, I'll be left with a 4. So the answer simplifies to 10x plus 5h plus 4, which is not too bad considering what it looked like before. That was number 64. All right, this is the last one we're going to go through on 2.2. And we're talking about this function here, x divided by 2 minus x. Well, this one doesn't look very pretty. When we put our f of x plus h and try to figure out what that is, everywhere I saw the x, I'll now put an x plus an h. And here I saw an x, so now I'll put an x plus an h. And when I distribute that minus through, I get this. So this right here, circled, is my f of x plus h. But now, to put it in my difference quotient, I have to take this minus this and then put it all over h. So I have my f of x plus h minus my x over 2 minus x. Now I'm going to do this in pieces. I have not divided by my h yet. What I'm going to do here is simplify this first before I divide by my h. I need to get a common denominator. I cannot subtract them like they are. So I'm going to multiply this one by 1 in the form of 2 minus x over 2 minus x. I'm going to multiply this one by 1 in the form of 2 minus x minus h. 2 minus x minus h over 2 minus x minus h. Yes, you have to do that on a test. It's tedious, but you won't have to do it more than once on this one. You may have more than one difference quotient, but I won't make you do more than one of these, okay? So now when I multiply this together, I'm not going to worry about the denominator. What does the numerator become? These two denominators are now the same. So I can combine the numerators, but let's see what I get. if I take 2 minus x and multiply it by x plus h, I'm going to get 2x and then a minus x squared for the inside. The outside is a plus 2h. And the last is a negative xh. Okay, so that is this numerator multiplied together. Okay, so now we've got a minus sign. And I'm going to put another parenthesis so I can keep it all together. And now I'm going to distribute this x through. So it's a minus 2x. And then, so the minus was out there. So 2x. And then a minus x squared. And then a minus xh. Loads of fun. Okay, now all of this is over this common denominator, which is, bless you, 2 minus x times 2 minus x minus h. And mind you, I have not yet even divided by the final h that is in our quotient yet. So I'm going to get another board here, and we're going to continue that problem. Okay, so here, what I have here, before I write it down, is we have a 2x, and over here in this one that we're subtracting, we have a 2x. Okay, so we have a 2x here and a minus 2x here. Right? We have a minus x squared and then a minus x squared. So those are going to cancel. Okay? We have a negative xh and a minus a negative xh. So those are going to cancel. So can you see that what looked horrible has everything cancel except for one term? And that one term is a 2h. And that's the only thing on the top that did not cancel. So now what we have is 2h divided by that long denominator, 2 minus x, times 2 minus x minus h. Now, all of that is divided by h, because remember at the bottom of the difference quotient, we have an h on the bottom. And we performed all the steps except we have not canceled that h. Now remember, when we divide by h, that's the same thing as multiplying by 1 over h. So since I've already got a complex fraction here, we'll just divide by h by multiplying by 1 over h. And then it's maybe a little bit easier to see that this h and this h are going to cancel. And our final answer is 2 over 2 minus x, 2 minus x minus h. And that should be our difference quotient. And I believe it is. That is the end of 2.2. And I hope you've learned a lot. Those difference quotients take some practice. They're tedious. You won't have a huge amount of them on the test, but you will have a few. And you'll probably have one that requires this kind of a fraction work. This is Mrs. A, and may God bless your day.